We will now work on the SeiRA software. As we know that the software has 3 modules: AutoPick for picking the first breaks, then we have Refract for travel time inversion of the picked arrival times, and finally StatCalc for creating a near surface model and computation of statics. This is the startup interface of AutoPick module. We create a new project. Let's name it PGN. Now within the project, we can enter the general information. Let's suppose the project name, the company name, the crew number, processed by the client, and the date. Next we are going to load the navigation data. For this we have selected 4 lines for the demo project. So we select the 4 datasets and add them to the project. So once the navigation is loaded, so in this small GIS window, the seismic lines will be displayed. Next, based on our geophone's layout geometry, we have to enter the offsets. For this we have an editor and we can enter the number of geophones, and we can finally one by one enter the offsets. Let's suppose the first one was 5 meters, then the next one was 10 meters, the next is 15 meters, and so on. And finally, once all the values have been entered, we can press the save button and save the offsets in a file. This file has already been created, so we can load this file, and here we have all those offsets. We now load this offsets file into the project. So now this offset file has been loaded. On this left side we have the project explorer where all the data components are listed. So here we have the 4 navigation files. Then this is the surface offset file. Next we are going to load the seismic refraction data. For this we have 2 options. We can choose the auto link option when the line name, picket numbers, as well as the forward and reverse shooting tags are defined in the file headers. So currently we would be using the manual link option. So this is the dialog for loading the seismic data. Here we can see the 4 seismic lines are already listed. We generally need the observer reports where the line name, the picket numbers, and the forward and reverse shooting files are listed. But currently for this demo project, all the Sec2 files have been named in such a way that they contain the line name as well as the picket numbers, and the forward reverse shooting tags are given in the file name. This makes it easy to load the seismic data according to the geometry. So as we can see, the first file indicates line number 139 and its picket is 204. So we will click picket 204 and we can see the line name and the picket numbers have been defined. And since the first file has F at the end, so it means it's a forward shooting file. So I would just click it and you can see this file has been loaded here. Now next file is for the same line and for the same picket, but it is a reverse. So I select reverse and click it. So in this way, forward and reverse shooting files have been loaded for one picket. Now the next picket is 254 for the same line. So we scroll down to picket number 254, double click it, and a new record is created. Now again, I click the forward and then double click the file. So it has been registered in the database. Then I select the reverse option and then double click the next file. So in this way, for all the pickets we would be loading the data. Next we have to define the trace selection. In the forward shooting, we have the first trace as trace 1 and the last trace as 24. Similarly, in the reverse shot, we also have 1 to 24 traces. And let's clip the maximum time to 150 milliseconds. because we expect that all the first arrivals will occur before this time. We also select this reverse option so that the reverse record is displayed in the reverse order, and then we click OK button. So we can see the two pickets have been displayed on the GIS. Now if I click on this point, the forward and reverse shooting records will be displayed. Similarly, if I click on the second picket, the forward reverse shooting records will be displayed. Next we define the output files where the picked arrival times and the computed velocities and thicknesses of the weathered and sub-weathered layers would be stored. So here we have to define the prefix for all the files. By default it is AP for AutoPick, but we can define a short name for the project, and then we have two options for naming the files. The first one is serial number, where each file will have a serial number, that is AP1, AP2, AP3 and so on, while the other option is AP followed by line name underscore picket number. So this would be a more viable option because from the file names it would be easier to identify the line name and the picket number to which it belongs. Now let's do some processing on these files. As we can see, the software has a number of processing modules. We select the scale max. Here the RMS amplitude has been set to 40,000. We keep the default parameters, select this data and click OK. So we can see the gain has been applied and all the traces will have the maximum RMS amplitude of 40,000. Similarly, we select this data and again select the gain and apply it. Next we select the AutoPick square wave module. We keep the default parameters and apply the AutoPick. So we can see the AutoPick module has automatically picked the first breaks. Similarly, we select the second data and again apply AutoPick. In this way, we can apply the same process to the next shot, that is first the gain followed by AutoPick. In this way, we will apply the gain as well as AutoPick to all the data shots. Now if we click on this picket, the seismic data for the forward and reverse shooting records will be displayed, and along with that the interactive tools will be displayed. Here we have a number of options, like we can zoom the data, then we can select a portion of the data to be displayed in a zoomed window. Then we have this option to change the direction of the display. Then we have this option through which we can display the trace and sample information. With this option we can increase or decrease the gain using this slider, and we can also clip the amplitudes using this slider. With this option we can interactively mute any of the traces. We can click and drag and mute any number of traces. We can undo this process. Similarly, using this option we can change the polarity of a trace or a group of traces by click and drag, or using this option we can change the polarity of all the traces in the record. Next we have all the interactive manual picking tools. And finally, this is the color attribute display, where the amplitude can be displayed in the form of colors. We select the base value to 8000. We can change the display option. Instead of the function, we can select the ticks only. Here we can see other options. We can change the colors as well as set the vertical as well as horizontal scale for the data. Now we can see the picks are displayed in the form of separate lines. But as we can see, this would become quite difficult to apply one by one the gain as well as AutoPick to each of the forward reverse shots. For this, the software has the option to create a job. We go to the job flow option and select a new job, and the job editor is created. we select the same gain module, which is scale max, keep the default parameters and click OK. So a script has been generated. Similarly, we select the AutoPick module and with the default parameters, we click OK. So again, a script is generated. So in this way, we have created a two-step job. And now we save this job. Now we can load this job in the project. Now we again click this picket and the seismic data is displayed. We select this data and click Run Job option. So you can see now instead of calling those modules, with a single click, the two-step job is applied. In this way, we can create a job with multiple processing steps and the whole job would be executed with just a single click. Similarly, the software also has the Run Job by Default option. When this option is selected, we click the data point and just on loading the data, the job has been applied. Now I click the second data set and you can see the gain has been applied and the first breaks have been picked. So in this way, we can see it is much more convenient to pick first breaks on multiple forward-reverse shooting points using the job option. This was just a temporary project. The original project has already been created, so we load the complete project. So for the same dataset, we can see we have those 4 lines and refraction data has been loaded for a number of pickets. We can randomly click any of the pickets and their respective datasets would be displayed instantly. In case of multiple datasets, we can also scroll down and see all those datasets. In addition to this GIS display, the software also has a data explorer where the 4 lines are listed in a tree and all the pickets where the seismic data has been loaded are displayed. So currently we can see this first picket has been selected and its data is being displayed. So in the GIS as well as in the Data Explorer, this picket is highlighted. Now if I click this picket on the GIS or on the Data Explorer, the corresponding data would be displayed. And this way we can access the seismic data either from the GIS or from the Data Explorer. The software has another option called the full project processing. So once all the data has been loaded and the jobs have been defined and they have been loaded into the project, we can use this full project processing option. Here we can see we have 2 options, job-based automatic and interactive processing, and the other is job-based background processing. If we use this option, the seismic data would not be displayed and on the back end, all the data would be processed and first breaks would be picked. But then we would need to QC the data. Therefore, we will select this option where one by one each picket data is automatically picked and displayed before the user to QC. And if required, the user can also interactively use the manual picking tools to edit the first breaks. So we select this option and click OK. So here we can see the first breaks have been picked and everything is OK. So we press the next button and now the data for the next picket is displayed and automatically picked. We click the next button, everything is fine, and so on. We can process the whole project. So we can see it's quite easy. Here we can see the first breaks have not been correctly picked, so we will select the manual picking tools to pick the first breaks. So I go to this trace and click the right mouse button. Since there is no data here, so I have to select the force picking tool. Basically, we have three types of picking tools. The first one is manual pick, where we go to any trace and click the left or right mouse button, and accordingly it would pick the first breaks. Now since we have manually picked the first breaks, we will press the save button so that the modified picks have been saved. And now we click the next button. So in this way we will continue picking the first breaks, and wherever there is a problem we can correct it. Like in this case, again we have some problem. Now I will select the second option, click here and then here, and the missed picks have been correctly picked. We press the save button and then move forward. In this way, the first breaks for all the pickets in the project are picked. So finally we save the project and move to the next Refract module. Now this is the Refract module. Apparently it appears to be similar to the previous module. So we load the same project. So this is the same GIS, but previously we had seen as the first breaks were being picked, there was a red circle around each of the pickets indicating that the data for this picket has been processed. But now we don't see those red circles. This is because for the previous modules, the first breaks for all the pickets had been picked, and therefore there were red circles around them. For this module, the picked arrival times need to be further processed for travel time inversion. Now if I click this picket, we will see that instead of the seismic data, a time distance graph is displayed. Here again we have neural networks for automated layering of the data. After auto layering, the best fit lines are fitted for each segment of the data depending on the number of layers. We have the option of manual layering of the data. If we don't agree with the computer, we can select this option for manual layering and we click here, and let's suppose we say this is the first layer. We click here and therefore for all these points it will fit a best fit line. Now for the second layer we select this point and then this point, and we can see the best fit line has been fitted through the data. Now we click this button to process the data for the reverse side, and now we click this point and then this point. The best fit has been fitted, and for the second layer again we click here and here, so the best fit line has been fitted. We can also undo this best fit, and finally we press this button to process the data, so all the parameters have been computed. We also have the option to view this time distance graph in Design CAD, from where it can also be printed. Now we also need to define the static computation parameters, such as the datum height, let's suppose it is 50 meters, and replacement velocity, let's suppose we set it to 2200 meters per second. Now similar to the previous AutoPick module, we also have the option for full project processing, where we will select the automatic as well as interactive processing option and click OK. So we can see the time distance graph for the first picket has been displayed along with auto layering. As everything is fine, so we click next button. Here we can see we don't agree, so we will do the manual layering. Click here and here and here. We go to the reverse side. So now it's done. Now we move to the next picket. Here everything is okay. So in this way we will process the arrival times for all the pickets and compute the velocities and thicknesses of the subsurface layers. Finally we will save the project and move to the third module, StatCalc. This is StatCalc, the third module of the software. We will now load the same project in this module. Again we have the same GIS, but now on clicking the picket we will neither get the seismic data or the time distance graph, but here we would only get the computed velocities and thicknesses of the weathered and subweathered layers. Before further processing, we set up certain additional parameters. Here we have defined the maximum number of pickets have two layer cases. The datum height and replacement velocity have been already defined in the previous module. Then finally we have to set up the filter percentage tolerance, and for that we can select velocity as well as velocity and depth, but we will select only the velocity, and the tolerance has been set to 40%. The velocity and thickness values are only available at these highlighted pickets, and these values would be used to interpolate velocities and thicknesses at rest of the pickets. But before using these pickets for interpolation, the software has a specialized algorithm where for any given picket it will select its nearest 6 neighbors, and using the inverse distance weighted method it will interpolate the velocity values from the surrounding 6 neighbors, and then it will check if the velocities of this picket are within the 40% tolerance limits. Then this point is considered okay. Otherwise, this point would be filtered. Let's suppose the interpolated value from the surrounding neighbors is 1000 meters, and as we have set the tolerance limit to 40%, then 40% of 1000 is 400. So it means 1000 plus minus 400 would be the tolerance limit for velocity. Thus, if the velocity of this point is between 600 to 1400 meters per second, this point would be considered okay. But if its velocity is lower than 600 or greater than 1400, this point would be filtered. In this way, using this filter, if any of these pickets have erratic values, those pickets would be filtered and would not be used in the interpolation process. Now once these parameters have been set up, we can use this button for computation of statics, or we can use the menu option. We select 3D gridding and define an output file. And here we can see a complete report has been generated, where we have the line number, the picket number, the XY coordinates, elevation, then elevation statics, weather glare statics, and the total statics. This red record indicates that this is a refraction point because these are the pickets that have been used in the interpolation. On the map we can see some of the pickets have been crossed, which indicates that these have been filtered as their velocity values were beyond the tolerance limits. So the statics report has been saved as a text file which can be used in the processing center for application of field statics. Now from the setup we can also load a color spectrum, and using the view option we can select elevation. So we can see based on the elevation values the lines have been color coded. Similarly we can select the statics option, and so the lines would be color coded according to the static values. So in this way it gives a good visualization of the variation of statics. The computed velocities and thicknesses as well as statics can be exported using the Visual Oil software to Surfer or any contouring software to generate contour maps of velocities, thicknesses as well as statics. So this was the complete workflow for processing refraction data for computation of field statics. Thank you.